All right, welcome to physics. This is our final activity for quarter one. You've made it almost. So to wrap up quarter one, we really want to finish talking about motion, and our last little piece of motion here is still around the idea of constant acceleration, but it's a concept called free fall. So just based on the word or words free fall, you might have an idea of what it's referring to. But we really want to make sure that we have an understanding of this concept in terms of physics and how the physics world will talk about it. So to help you with that, I found this video that explains what is free fall, and it does it much better than I can. As you can see, this guy jumping out of a plane, and you'll watch this video and answer a few questions. Okay, so one of the things you're going to learn from the video is what is free fall. So you're going to listen for the definition. Then uh, in the video, or if you need to, you can Google the answer or look on page 54 of your student textbook. uh, what is the gravitational force of gravity? Okay, that's going to be related to our discussion here. And then three, if an object is in free fall, what would be the rate of acceleration for that object? Again, it'll say it in the video, but you can also find the answer on Google, and you should be able to find it on page 54. And then what do you notice about the force of gravity from question 2, and the rate of acceleration of objects in free fall from question 3? So what do you notice? Can you compare those two numbers? Next, I wanted to remind us about a concept that is related to this free fall idea. So in middle school, theoretically, your teacher should have gone over the universe and some of Newton's laws of motion. And one of the key concepts was the law of inertia, or Newton's first law of motion. And Newton's first law of motion is an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So again, I'm going to sit here, and I would stay sitting here unless an unbalanced force moved me. Okay, unless I create a force. This textbook will sit on the desk until something applies a force and moves it. It will stay at rest. And then the same goes for objects in motion. And this one we have a hard time seeing here on Earth, but is very common in outer space, which is why in middle school you're supposed to talk about that. So in outer space, there's no resistance, air resistance. And so objects in motion, you will see, will stay in motion. And that's how we get shooting stars. That's how we get our orbits of the planets and so forth. So the law of inertia, we know to be true. It has not been discredited. So with that, okay, how does that come into play with our free fall concept? And so I want you to think about these questions. What is the unbalanced force that makes an object accelerate towards the ground when dropped? And you have a few options here. The concept would be, you'd be able to pull that out from the video above as well. Okay. Next, do all objects free fall at the same rate? This is just a yes or no question. You can choose to explain your answer if you would want, but you don't have to. But we're also going to go into this a little bit further. Okay, so do all objects free fall at the same rate? Then I want you to form a hypothesis. You're about to watch a video here. Okay, and what will happen if you drop a bowling ball? Okay, picture a heavy bowling ball, and then a feather, a light bird feather. What would happen if you drop them at the same time? Okay, you're holding them, you drop them at the same exact time. Okay, I want you to come up with a hypothesis. So I gave you a little sentence frame here just to help remind you. if, then, because. And so typically you might restate the question. Okay, so what will happen if you drop a bowling ball and a feather at the same time? So you might say, if you drop a bowling ball and a feather at the same time, then, okay, that's when you explain. You know, will they hit the ground at the same time? Might be where you approach that. So if you drop a bowling ball and feather at the same time, then they will not hit the ground at the same time. They will hit the ground at the same time. Whatever you're wanting to argue, and then because, okay, you try to explain it. That is a very important part of the hypothesis. You got to think about why. Once you've formed your hypothesis, now you can watch this video, and you're going to see two different scenarios. And so I'm going to have you make observations for kind of part one, which happens in the first minute or so, and then part two, which is the second half of the video. So one is going to be with air resistance, the other is going to be without air resistance, and you can kind of see here, this Brian Cox will be visiting the world's biggest vacuum. Okay, so some of you might already have an idea of what this will do, but I want you to think about these observations. You will select all that apply. Okay, so multiple selections. It's not just one correct answer. Okay, and same with this as well. Then I have two questions to check for understanding. So number 10 is an object in free fall if there is air resistance? So if air resistance is present, is an object technically in free fall? Yes or no? And then we can explain and argue that. And then 11, in your own words, why did the bowling ball and feather, okay, kind of go into a sneak peek of the video, hit the ground at the same time when dropped in the vacuum? Please include the following terms. So in your response, I want you to include air resistance, free fall, acceleration, and gravity. And this really will help demonstrate to me if you're understanding this concept of free fall. Let me know if you have any questions. Please attend class if you need help or have questions. And thank you for all your hard work.